Picking up with question 13 here, a dice game at a fair costs $1 to play. A roll of 1, 3, or 5 results in winning 50%. Result of a roll of 6, you win $5. Any other roll is a loss. What's the mathematical expectation? And then, is this a good fundraiser for the fair? So in other words, what do the people running the game expect to gain or lose in this game? All right, so a 1, 3, or a 5. 1, 3, or a 5, you're going to win 50 cents. But be careful, because you paid $1 to play. So if you, quote, win 50 cents and you paid $1 to play, you're really coming out 50 cents behind. Okay? And then it says a roll of 6, you get $5. But you don't really get $5 because you paid $1 to play. So a roll of 6 is a gain of $4. And that means that for a 2 or a 4, you just totally lose. So you're going to lose your $1. So that's minus $1. Okay? So let's look at our probabilities here. 3/6 of the time, which is 1/2 the time, you're going to lose 50 cents. Okay? 1/6 of the time, you're going to come out ahead $4. And 2/6 of the time, or 1/3 of the time, you're going to lose $1. And we can work that out. We can see what happens. So if I stick that into the calculator, let's find out what I get here. Okay, if you run the numbers here, that's going to end up being 0.083 repeating, which is going to be about 8 cents, technically 8 1/3 cents, but let's say it's about 8 cents. Okay, what this suggests is that you can expect to win 8 cents every time you play the game, which means that the people who are running the value in the game, if your expected value is to win 8 cents, their expected value is to lose 8 cents every single time somebody plays this game. So this is a terrible fundraiser, because the people running it should be expecting to lose money. Not a good setup for them. But if you get a chance to play a game like that, play it. Play it thousands of times. You'll win a lot of money. All right, a student has a 90% chance of correctly answering any question on a 5-question quiz. What's the probability she misses at least one problem? And this one, they want to the nearest 0.1%, which of course is 1 decimal place. All right, so there are 5 categories here. We always want to think in terms of categories, and we want to think about, is this an and or an or situation with those 5 categories? Okay, now here's the problem. Missing at least one problem. That could be that you miss the first problem and then get the next 4 right. That could be that you miss the second problem and get the next 4 right. It could be that you miss the third, get the next 4 right, so on and so forth. You could miss the first 2 problems and get the last 3 right. You could miss problem 2 and 4 and get the other 3 right. You could miss problem 1 and 5 and get the other 3 right. All kinds of other possibilities, right? You could miss 3 different questions, and you can miss like the first 3. You could miss the last 3. You could miss 4 out of 5. You can miss all 5. Anyway, problem is there are too many different things that can happen to try to count all that up in a decent amount of time. So this is a problem where I would suggest using the complement. Remember, the complement is to find the opposite. The complement of this would be to miss, the complement of missing at least one problem would be to miss no question. And if that's the case, if we're looking for the probability of missing no question, there are 5 different things that can happen, right? 1, 2, 3, 4, 5. So I'm going to draw blanks for my events. You want to word this as an and or, okay? Missing no question, that means you're getting the first right and the second right and the third right and so on. And, of course, for independent events means multiply. So there is a 9/10 chance or 90% chance of winning, getting the first question right. Actually, let me do 0.90 here. This will be easy to calculate. And a 0.9 chance on the second one here, and a 0.9 chance on the third, and a 0.9 chance on the 4th and 5th, okay? And if we multiply those together, we're going to get a decimal that's about 0.59049. Now keep in mind, that's the probability of missing no questions. That means all the rest of the time you miss at least one. So you can take that away from 1, that's going to give you about 40951, which is about, does it say nearest tenth of a percent? So that's going to be about 40.95, which will actually be 41.0% when you round up, right? Because it would have been 40.95, but that 5 there is 5 or greater, so we round up, goes to 41.0%. All right, make sure we got our rounding from middle school okay too, right? All right, and the next question here is number 15. Number 15 says we have 7 juniors, 4 seniors, 2 sophomores. They're entering a drawing to win prize. As a simplified fraction, find the probability that 3 seniors are drawn in a row. Okay, so let's see what's going on there. So we have 7 juniors, we have 4 seniors, and we have 2 sophomores. And we want 3 seniors in a row. Okay, so again, our strategy of breaking this up into and or, that would be senior and senior and senior. So we want 3 seniors in a row. There are 13 total, right? So you have a 4/13 chance of picking a senior. It seems to imply that you can't win more than once. So that means you're down to 3 seniors out of 12 after you've chosen one, and then you'd be down to 2 seniors out of 11. And you might want to do a little simplifying first. For example, 4 goes into itself once, 4 goes into 12 3 times. Let's see, across the top there, it looks like we're going to get a 6. Let's see, 3 times 11, that's 143, right? Or 13 times 11. And then we're going to multiply that by 3. And so it looks like 6 over 429. And I don't think that's going to simplify. Oh, nope, they're both divisible by 3. So that's going to be 2 over 143 as our final probability. And again, it doesn't say to round, so let's leave it as a fraction. All right, part B. At least one junior is chosen. Again, if you're trying to break this up as and or, that could be, the first one's a junior and the next 2 aren't. The second one's a junior and the other 2 aren't. The third one's a junior and the other 2 aren't. But that could also be 2 juniors, and that could be in different orders. That could be 3 juniors. That's complicated. So again, I'm going to try to find the opposite of that. The complement of that would be no juniors, okay? And then we'll subtract that from 1, and that would tell me the probability that I have some juniors, which is the same thing as at least 1 junior. So not getting a junior, that would be not a junior and not a junior and not a junior. Okay, out of the 13, 6 of them are not juniors. So there's a 6/13 chance of not a junior on the first, 5/12 chance of not a junior on the next, and then there's a 4/11 chance of not a junior on the last one. Let's divide the 4 out of this, get this down just a little bit. And let's see, on top, we're going to end up with 30. And on the bottom, I think it's 429 again, okay? So again, that's the probability of no juniors. At least 1 junior would be the opposite of that. So I can take 1 minus that. 1 is 429 over 429. And we're going to subtract 30 over 429. And let's see, that's going to end up being 399 over 429. And let's see, does that simplify? That'll simplify to 133 over 143. All right, so there's part B. Going to part C. 2 juniors and 1 senior if 3 are selected simultaneously. All right, so remember when you choose something all together, you just have 3 names in your hand, that sort of thing. There's no ordering involved. These are usually best done if you do this using combinations, okay? Otherwise, you're going to have to look at every single possible order that you could do. What's the probability of getting a junior and then another junior and then a senior? Or add, what's the probability of getting a junior, a senior, and then a junior? Or what's the probability of getting a senior and then a junior and then a junior? You'd have to add all 3 of those up. And that's not terrible, but I think it's much faster just to go back to basic probability and say, okay, how many ways can I be successful? What's my total number of possibilities? And so my total number of possibilities is very simple, right? I'm choosing 3 people from a group of 13. So that's a combination of 13, choose 3. I want 2 juniors and 1 senior. So how many ways can I pick 2 juniors if I don't care about their order? There's 7 of them, I'm picking 2. I want 2 juniors and 1 senior. There are 4 seniors, I want to choose 1 of them, I don't care about the order, okay? And so we can work this out. 7 choose 2 is going to be 21. 4 choose 1 is 4. 13 choose 3. It's going to be 286. So that's going to be 84 out of 286. I think that simplifies. It's going to simplify to 42 over 143. All right, and then we'll do another video for the next set.